Okay, good morning everyone and welcome back to 115. Today's day 4 and what we're going to talk about is more of section 2, or A.2 that is, covering polynomials. And if we have time, we're also going to start A.3. So A.2 we started last time is all about polynomials. So we talked about their definition and how to add and multiply them, and today we're going to talk about how to factor polynomials, specifically quadratics. Maybe we'll talk a little bit more later about how to factor like cubics or quartics or higher degree polynomials, but we're not going to talk about that in this section, even though there is some material on it in the book. So I'm going off of the book just a little bit in this section to not talk about those things because frankly, I don't think that they're very relevant. I've never had to memorize how to factor a cubic in all of my years of math, so I'm just going to teach you a better way to do it later in the semester. Okay, so the homework. We have 2 homeworks which are due tomorrow. Right, today's Wednesday. So 2 homeworks due tomorrow. Everything has already been covered for those homeworks. If you have any questions over that homework, I have office hours today from 10 until 11:30 on Microsoft Teams. So if you're not added into the Microsoft Teams, send me an email and I will add you. But I think everyone should be in there. All you do is you go to Microsoft Teams, click join meeting, and I'll be in there and you'll see a screen just like this and we can talk over homework problems or whatever. There's also going to be a quiz, don't forget, on this coming Tuesday, and it will cover sections A.1, A.2, and A.3. Okay, I already did attendance, so does anyone have any administrative questions before we start in on material? Okay, if not, then let me remind you what we were talking about last time. So last time we talked about the definition of polynomials, and the first thing we defined actually was a monomial. So that's a polynomial that just has one term. So a monomial has the form a times x to the power n, where a is a constant, okay, or a number which is not 0, and then n is basically a whole number if you're taking our definition of the whole numbers. Another way to say that is non-negative integer, right? So it's an integer that's not negative. So we throw out -1, -2, all those other integers, and we're just left with 0, 1, 2, 3, ... Okay, so that was a monomial, and we said that a polynomial is just a sum of various monomials, okay? So we can take different powers of x and add them all together, or subtract them, and we get a polynomial. The only rule about the polynomials is the power on each term has to be a whole number, right? Has to be a non-negative integer. Okay, so that was polynomials, and we learned about standard form of polynomials, which is where we just list them. We combine all the like terms, and then we list each term in decreasing order of degree. So we don't want to put x squared before x to the 7th. We want to put x to the 7th before x squared. So that was standard form. And then we talked about how to add polynomials, which again is just about combining like terms. The only thing we have to be careful about when we're combining like terms is the sign, right? So if we want to subtract a whole polynomial like x squared minus 3x plus 2, we want to subtract that whole thing, then we want to make sure that we distribute that minus sign onto all of the terms. Okay, then we learned how to multiply polynomials, and this made use of that distributive property that we learned. So the distributive property tells us that if we're going to multiply 2 polynomials together, then what we need to do is multiply every term of the first polynomial times every term of the second polynomial. So in this case, since there were 3 terms in the first polynomial and 2 terms in the second polynomial, I ended up with a total of 1, 2, 3, 4, 5, 6 summands. Okay, summand is a word that we use for the component of a sum. So we have 6 summands here coming from 3 times 2, right? So that's one way that you can check whether you made sure you got everything. So are there any questions about polynomials so far that, I don't know, just haunted your dreams last night and you need to get off your chest? All right, crickets. Then let's go ahead and start for today. And the first thing that we're going to talk about is factoring, factoring polynomials. Okay, so the very first thing that we're going to talk about is the FOIL system. So the FOIL system is used when we want to multiply two binomials. Okay, so this is for multiplying binomials. So what I mean when I say binomial is I mean it's a polynomial that has two terms. So the Latin root bi means two. So if we have two terms, then we have something like the following. We could have x plus 2 times 2x minus 3. Something like this. And the FOIL acronym stands for first, outside, inside, last, in terms of what we need to multiply together and add up in order to multiply these. So we already talked about how to multiply polynomials. We need to multiply every term of the first one times every term of the second one, which, since we have 2 and then 2, it's going to be 4 total summands, which are the F, the O, the I, and the L of the FOIL system. So what it says is basically you want to multiply the first entry of both of these together. So first, outside, inside, and then last. So let's do it. The first entry of each is going to be x times 2x, which gives us 2x squared. Then I get a plus sign. Actually, I'm going to get a minus sign, right? Because of this negative 3. So to do the outside, I need to multiply x times negative 3. Okay, so don't forget to keep that sign in mind when we're multiplying these. So I'm going to get minus 3x. And now I need to do the inside. What I mean by inside are the two, which are, I guess if you think about this as like, okay, outside is this direction, and then inside is this direction. Then you can see 2 and 2x are going to be my inside terms, so I get a plus 4x for multiplying those together. And now I need to do the last terms, which in this case are 2 and negative 3, so I get a minus 6. Okay, I think FOIL is probably, for the most part, familiar to you all. So let's talk about how to go in the opposite direction. So what we want to do ultimately is take something like, oh, by the way, once we get to this part, we should combine like terms, right? So we'd get 2x squared plus x minus 6, right? So what we're going to talk about next is how to go in the reverse direction. If I have something like this, how do I figure out what the factors are? Okay, so this is called factoring. And we can do it for basically linear expressions or quadratic expressions, or higher degree as long as we have a factor of like x or something like this. So let's first talk about the very first thing you do anytime that you're factoring, which is to take out the largest common factor from every term. Okay, so in this case, if we look at 9 and 18y, we know that the largest common factor for both of these two terms is going to be what? 9, right? We can take a 9 out of both of these, so I can rewrite 9 plus 18y as 9 times parentheses, so I'm kind of doing the reverse of a distribution here, right? Or I'm doing the reverse of the distributive law, right? I'm pulling out the 9. So what should be inside? If I was going to distribute 9 onto two things, and I would get 9 and 18y, what should my two things be inside? 1 and 2y, right? So I can't take the y out because there's a y in the right side but not in the 9. So I can't take a y out. I have to leave it inside as a 2y. So if I multiplied 9 times 2y, I'd get 18. If I multiplied 9 times 1, I would get 9. And by the distributive property, you would know that this is equivalent to that. Okay, so that's pretty simple. And we can also do it with like powers of x is what this one is getting at. So what's the common factor between all of these three terms? The largest common factor. We can take an x squared out of each of them, right? Okay, so in that case, I'm going to get x squared, and someone help me out. What goes in my parentheses here?
7x squared plus 3x plus 1.
7x squared plus 3x plus 1. Very good. Thank you, Sully. That was Sully, right? Okay, so this is basically what we do when we are taking common factors out. And it's the first step that we want to always take when we're factoring, because what it's going to do is it's going to simplify the rest of it significantly, right? So I don't know about you, but I would be much happier factoring an expression like 7x squared plus 3x plus 1 than I would be trying to factor something like 7x to the 4th times 3 plus 3x cubed plus x squared, right? It makes it simpler. And now we can go ahead and try to figure out how to factor this guy. Okay, so we're going to talk about a couple of different techniques for factoring quadratic expressions now, which the general form which I'm going to use for a quadratic, okay, is this form, right? So I'm going to say all the time ax squared plus bx plus c. And this is what I call the general form of a quadratic expression, where a, b, and c are assumed to be different numbers. Okay, so x is always going to be a variable, which is different than a constant. A variable is a placeholder for a number that could take very many values, any value that we want. But a, b, and c are going to have a fixed, specific value when we're working on like a problem, for example. Okay, so let's talk about the first method for factoring quadratics. And I like this method the best when a is equal to 1. So what does that mean for our form? Well, if a is equal to 1, then this would be 1 times x squared. So I would get just x squared plus bx plus c. So if I have a form like this, then I'm in good shape for factoring using this method, which is that we are going to look at the factors of c. Okay, we're going to look at the factors of c, and we're going to look for two numbers, basically, that multiply together to get c and add or sum together to get b. Okay, that's going to be the goal. Okay, so we can factor by finding two numbers whose sum is b and whose product is c. Okay, so how are we going to try to do that? Well, what we're going to do is we're going to take our c and we're just going to list all of the numbers which we could multiply together to get that number. So 15, I could multiply 15 and 1, right? Or I could multiply 3 and 5, right? So those are the two different ways that I could multiply two numbers and I could get 15. And now I'm going to look at these numbers, these pairs of numbers, and I'm going to check, are there any of those pairs such that if I added them together, I would get 8? And the answer is yes, right? If I add 3 and 5 together, then I would get 8. So this is how I can factor this. What am I going to get? I'm going to get x plus 3 times x plus 5. Okay. So let me ask you all a question now. How can I check if I factored correctly? I can refoil, right? If I foil this guy, then I should get back what I started with. So let's do that. If I foiled it, I would get x squared plus 3x plus 5x. Okay, actually, technically, I would get plus 5x and then plus 3x, right? If I'm doing it in the correct order. So I would get plus 5x plus 3x plus 15. And then I would combine like terms and get x squared plus 8x plus 15. And I'm happy because that matches what I started with initially. So that's one way to check your work. Any questions on that first example? No questions? Okay. Maybe this is too easy for you all. No, I'm kidding. Okay, let's do another one. This one's harder because we got minus signs in the mix now. Okay, so what am I going to do? All I'm going to do is I'm going to list all the things that I can multiply together to get negative 16. What am I doing? I want something like this. So 16 is equal to, or negative 16 could be something like negative 2 times 8, or it could be negative 8 times 2, or it could be negative 4 times 4, or it could be negative 16 times 1, or it could be negative 1 times 16. Am I missing any? 2, 8, 4 and 4, 16 and 1. I think I'm good. Okay, so yeah, I didn't list 4 and negative 4 because it's identifiable with this one. Okay, so now we want to look for a pair such that if I add it together, I get negative 6. So what's the pair I want? Negative 8 and 2, right? This is the pair I want. So I'm going to do x minus 8, right? X minus 8, and then I'm going to do x plus 2. Okay, easy breezy. So if you want to spot check your answer, by the way, one thing that I like to check is if this is a, oops, shouldn't have done that. If this is a negative number for b, okay, then the bigger number needs to have the minus sign in your factoring, right? Because when you FOIL, that one's going to be the larger, like, between the outside and the inside terms, right? Okay, so pretty standard stuff. Any questions about that one that we did with the minus sign? Okay, so yeah, this is pretty much the easiest form of factoring. It works great when we have the first number equal to 1, right? So, i.e., we have x squared plus something else, right? It gets a little more complicated when we have a, like, 4x squared plus 3x plus 1 or something like that. Before we talk about that, though, let's talk about polynomials which cannot be factored further. Okay, so polynomials which cannot be factored further are called irreducible polynomials, okay? Or technically, I guess you would call them irreducible over the real numbers. But you can just call them irreducible, and I'll know what you mean. So polynomials which can't be factored are called irreducible. So it's a little bit difficult to get your head around this concept at first because it seems like, well, shouldn't they all be factorable? And it turns out that they're not. So let's take a look at an irreducible polynomial, which is x squared plus 4. Now, you probably all know the quick and easy way to factor a difference of squares. But this is a sum of squares, okay? So if we want to apply our previous logic to this, right, we want to find two numbers whose sum is b and whose product is c. So what do I need to do? I need to find two numbers whose product is 4 and whose sum is 0, right? Because that's the b in this case. So we have a plus bx in here, and b has to be 0 because we don't have an x term. So B is 0, and C is 4 here, and A is 1. So we need two numbers whose product is positive 4 and whose sum is 0. Okay, why is this impossible? Can anybody tell me?
You're only adding.
Sorry?
You're only adding. There's nothing to subtract away. Like there's nothing that can subtract away.
Exactly. There's no two numbers whose product is positive and whose sum is 0. If the sum of two numbers is 0, then one of them is like positive and the other one's negative, or else they were both 0. So the way that we can get two numbers to sum to 0 is if we had something like A and negative A. But if I take A and I multiply it with negative A, what am I going to get? I'm going to get a negative number, which 4 is a positive number. Okay, so I can't take two numbers, add them up and get 0, and have their product be 4. Okay? So that's what we would call an irreducible polynomial. So anytime that you want to say a polynomial is irreducible, by the way, you will need to make an argument such as this in order to justify that claim. Any questions about irreducible polynomials? Okay. The reason that I say, by the way, irreducible over the real numbers is because we're only really considering real numbers in this class, but this polynomial actually is reducible or factorable if you use complex numbers. But yeah, we're not going to talk about that. Okay, so let's move on and talk about the grouping method. Okay, so this is what I like to use and what I would recommend that you use if A is not 1. Okay, and it consists of the following 4 steps. The first thing we're going to do is we're going to list the pairs of integers whose product gives us whatever we get when we multiply A and C together. Okay, whatever we get when we multiply A and C together. And then we are going to choose the pair whose sum is B again. Okay, so not that different from what we did last time. And then we're going to take our B and we're going to split it up into 2 different terms. Okay? And then we are going to group the first 2 terms and then the second 2 terms, and then we're going to take out common factors. So let's see this in practice. I think it's easier if you just see how it works. So let's follow the steps to the T. The first thing we need to do is list the pairs of integers whose product is A times C. What is A times C in this case?
36.
Negative 36, right? So negative 36 is what we need to get. What 2 numbers can I multiply together and get negative 36? Yeah, I could do 6 and negative 6.
Sorry, can you just leave the list? There's
Sorry?
just leave the.
Oh, the list of, yeah, sorry. Sorry about that. Okay, what other factors of negative 36 do we have?
18 times negative 2.
Yeah, we got 18 and negative 2, and also the reverse, right? Negative 18 and 2. And then what else do we have? How about the 2 that we started with? 9 and negative 4, or negative 9 and 4? Any others?
Negative 12 and 3.
Very good. Negative 12 and 3. And the other way around, 12 and 3, negative 3, right? Okay, any others? Yes, we got negative 36 and 1, and then negative 1 and 36. Okay, I think we got them all now. So what do I need to do according to the steps? I've listed all the pairs of integers whose product is A times C. I need to choose the pair whose sum, so I need to find the pair between all of these whose sum is positive 16. So which pair do I want? I want 18 and negative 2. So this is the pair that I want. And then what am I supposed to do? I'm supposed to split bx according to step 2. So what I mean by that is that I'm going to rewrite this whole polynomial in the following way. 4x squared, and then I'm going to do minus, or I could do, okay, I could do this 2 ways. I could do 4x squared plus 18x minus 2x, and then, what am I doing? Minus 9. I could split it like this, okay? And then we'll do it the other way later, and I'll show you that it works no matter which way you do it. Okay, so now what do we have to do? What we have to do now, okay, is group terms and take out common factors. So I'm going to rewrite this a little bit differently, okay? I'm going to do it like so. I'm going to group the first 2 terms together, 4x squared plus 18x with parentheses. And then I'm going to do a plus sign. And then I'm going to do my other 2 terms, which is negative 2x minus nine. Okay, this is fine. Yeah, this is fine. Okay, so I'm going to do negative 2x minus 9. Okay, and now what the step says is to take out common factors. Okay, so take out common factors. So I'm going to look at each of these 2 terms, and I'm going to take out the largest common factor between the 2 terms in each of these kind of subterms. So the first term is 4x squared plus 18x. What's the largest common factor there? I can take out a 2x, right? And then left inside, I'm going to have 2x plus 9, right? Okay, now let's do the same thing for the other one. What's the largest common factor between negative 2x and negative 9? I'm going to take out a negative 1. And then I'm left with 2x plus 9. Okay, so now what do I do? Well, I have a certain amount of a type of thing. Okay, by the type of thing, I'm saying I'm going to tell you that these 2 are actually like terms. If I have 2 like terms and I add them together, then what I get is whatever the sum of these 2 numbers is times that like term. Okay, so I can actually factor out from each of these terms. If you want to say it, you could say that we're taking out a common factor between these 2 terms of 2x plus 9. So what do I get? I'm going to get 2x minus 1 times 2x plus 9. So you can see that if I were to distribute the 2x onto this term, and then I distributed the minus 1 onto this term, then I would get back what I have in the line above. Okay, so that's another way to do factoring. Why do I like this method? I like this method because it works well when, okay, it's not what I wanted. It works well when A is not 1. Okay, any questions about this grouping method so far? No questions? Okay, let me show you how it works when you do it the other way, because I know that there's probably somebody out there in the class who, when I got to this step and I said I'm going to split it as 18x minus 2x, you said, why can't you split it as minus 2x plus 18x? And the answer is that you can split it that way, and let me show you how it would work. We would get 4x squared, so this is OR. We could do 4x squared minus 2x, and then plus 18x, and then minus 9. Okay, and then what would we do? We would put our parentheses around each subterm, and then we'd take out a common factor. So the common factor which we can take out of the first one is 2x, and then we would be left with, what, 2x minus 1? 2x minus 1. And then we would add, and then the greatest common factor in the second one is 9, and then we would get 2x minus 1 again. And then we would combine like terms and get 2x plus 9 times 2x minus 1. Okay, so it works both ways. It'll just permute the order, right? It'll permute the order. But that doesn't matter, because if you multiply two numbers, you can multiply one times the other or the other times the one and still get the same thing, right? 3 times 5 is the same as 5 times 3. So multiplication is abelian, I guess is the word that you would use. I forget what the like primary education word is for that. Okay, anyways, you can change the order. All right, so let's do another example here, just to really drive that one home. Okay, 6x squared plus 17x plus 7. So what do we want to do with the grouping method? I'm going to purposefully not leave the instructions on the screen. And what are we going to do first? Yeah, multiply A and C, right? So 6 times 7, we get 42. And now what do I need to do? List the factors, right? Need to list the factors. Okay, so what do we have? We've got 6 and 7, obviously. What else do we have? 21 and 2. And then 14 and what, 3? And also, obviously, 42 and 1. Did I get them all? I think so. It's 2 times 3 times 7 is the prime factorization. Okay. Yeah. All right, so we need to find what? What's my next step? I need to find the pair that adds up to 17, which is 14 and 3, right? Okay, so now that I've identified this is the one I want, what's the next step? What do I do next? Yeah, I'm going to rewrite the polynomial where I split the middle term. So 6x squared, which one should I do? 14 or 3 first? Does it matter? It doesn't matter. So I don't know, let's do 3. So plus 3x plus 14x plus 7. Okay, so now I've expanded this thing. How does that help us? Why is this 4-term polynomial? Isn't 4 terms more complicated than 3 terms? Why is 4 terms better? Yeah, I can take out common factors from these subterms, right? So I'm going to draw parentheses around these guys, and I'm going to take out the common factor, which is going to be 3x, and then what do I have left inside is 2x plus 1, right? 2x plus 1, okay, and then I'm going to add, and what can I take out of the second one? A 7, right? I can take out a 7. And what's left inside is 2x plus 1 again. So I take these two, 3x and then plus 7. That forms my new term, 3x plus 7. And then that's all being multiplied by 2x plus 1. Okay, so this is the grouping method. It works for pretty much everything that is easily factored. At least using integers. All right, any questions about the grouping method? Can I have a show of hands if you've seen the grouping method? Could you raise your hand for me before? Okay, so this is mostly review, I think. That's good. But if not, well, you've got the steps right here. You can write them down on a flashcard and put it under your pillow at night and absorb it. Okay, so let's talk next about a difference of squares. So this is a special case, x squared minus a squared factors as x minus a times x plus a. Okay, why is that true? So if a is a number here, by the way, so a is a real number. Okay, so using that notation again, what does this symbol mean? is an element of, right? And then what does this symbol mean? Real numbers, right? Is an element of the real numbers. Okay. Okay, so why is this true? Well, you can see it easily if you take x minus a and x plus a and you FOIL it. What would we get? We would get x squared plus ax minus ax minus a squared, right? So the plus ax and the minus ax, they cancel each other out, right? They cancel each other out. Okay. So that's how we factor a difference of squares. Okay, so the last thing I'll say for polynomials today will be that if you want to factor cubics and higher, we're going to talk about how to do that another day. The way that we're going to do it is using long division. So if you've seen before something like x cubed minus 1, and you want to know how to factor it, well, what you do is you can use the special formula or whatever, which I don't really think is worth memorizing. What I do think is worth knowing how to do is long division. And the first thing that you can see is that 1 is clearly a root of this polynomial. So you know that x minus 1 is clearly a factor of this polynomial. And what you do is long division. You take out x minus 1 from this polynomial, and then we'll talk later about how to actually do this long division. It's a whole deal. Okay, final questions about polynomials and factoring quadratics. I guess I'll throw one more thing in here. I don't know why it's not in this chapter. Why don't we talk about the quadratic formula? This is how you can get the roots. So if we have ax squared plus bx plus c, then the roots are x is equal to what? Anybody remember what it is?
Plus or minus the square root of b squared minus 4ac all over 2.
Very good. Negative b plus or minus the square root of b squared minus 4ac all over 2. Or is it 2a? I think it's 2a. Yeah. Okay, all over 2a. Okay, so that's how you can get the roots. If these are the roots, then you know that this is going to factor, by the way, as x minus this guy x minus this guy with a plus, and then we're going to get times x minus this guy with a minus. Okay, so those will be the factors. Okay, so if all else fails, you can use the quadratic formula, and you can get the factors that way. All right. So next up, we're going to talk about the next section, which is A.3. And A.3 is all about rational expressions. So there's that word rational again. What does that mean in the math world, rational? Oh, rational has the word ratio in it, and ratio brings to mind fractions, right? So rational expressions are going to be fractions where the numerator and the denominator are going to be polynomials. Okay, so that's the definition here. A rational expression is a quotient. That's another word we use for division or fractions. Is a quotient of polynomials. Okay, so I could take a polynomial like x squared plus 17, and I could divide it by another polynomial like negative 2x cubed plus 31x minus 1. Okay, so I can take two polynomials and divide them. And the major content in this section is going to be about how do I simplify an expression like that. Okay, how do I simplify an expression like that? Okay, so let's talk about how we simplify a rational expression. Well, it's pretty simple. The only thing we're going to do is we're going to apply the thing that we just learned to the top and to the bottom. So we're going to factor the top and we're going to factor the bottom. And then we are going to cancel out any common terms. Okay, so the same way that I would say if I had like 15 divided by 18, right? What would I do? I would factor the top into 3 times 5, and I would factor the bottom into 3 times 6, and then I would do what? I would cancel out the 3's, right? And then I would be left with 5 over 6. So the same way that I do that, I'm going to do the same thing with my polynomials. I'm going to factor them into what they are, like they're factors which can be multiplied together to get that thing. And then if I see anything common between the top and bottom, I'm going to cancel it. Easy as pie. Easy as eating pie, at least. I don't know about making pie. Okay, so let's see how we can do this. So we're going to get a little bit faster with this factoring. If you need a little more help or you want to go slower, come talk to me in office hours, please. So x squared minus x minus 6, how's that one going to factor? I think it's going to be x minus 3 and x plus 2, right? We agree with that? And how about the bottom? How am I going to factor that guy? It's a cubic. What am I supposed to do with a cubic? I just told you we don't know how to factor cubics, right?
Take out x squared.
That's right. There's a common factor. I can take out x squared. If I take out x squared, what am I left with?
X minus 3.
Just x minus 3. Okay. So what have I done? I've factored the top and bottom, and it says the next step that I'm supposed to do is cancel. What can I cancel? X minus 3. Let me use the red again. Okay, so in the end, my final answer is x plus 2 divided by x squared. All right. So this is how we simplify two rational expressions. Okay, this is how we simplify two rational expressions. Or actually one rational expression, which is a composite of two polynomials. Any questions on this process? Okay, let me modify this one in a way that sometimes I find confuses students. So sometimes what I see is people will get like a minus x cubed plus 3x squared. And what will they do? They'll take out an x squared and they'll be left with negative x plus 3, like shown. Okay, so when we see something like this, what you need to recognize is that these two factors actually can still be canceled, okay? X minus 3 and then negative x plus 3 are just the negation of one another, right? So if I had something like this, I can still cancel these where the top would be replaced by a 1 and then the bottom would be replaced by a negative 1. Okay, so if you get stuck in that trap, that's how you can deal with it. But the best thing to do probably would be to take out a negative x squared at the start, and then you would have positive x minus 3 inside. So let me fix this problem now, because I'm going to leave it as it was originally. Okay, so that's just a quick note. So these got canceled, and then we're good. All right. So let's talk about how we multiply two rational expressions. Okay. Well, we already learned how to do polynomial multiplication. And we know that if we multiply fractions, the only thing we have to do is multiply the numerator times the numerator and multiply the denominator times the denominator. So since we already learned how to multiply polynomials, multiplying rational expressions is going to be exactly the same, right? So let's try it. What would we get if we did something like this? Well, we would multiply the top times the top and the bottom times the bottom. We would FOIL in both cases. Okay, so we would get x squared plus 7x plus 1x plus 7 in the top. And then in the denominator, we would get x cubed minus x squared, and then minus 36x, and then plus 36. Okay, so that's how we would get our final answer there. And of course, you would want to combine like terms in the top. You could rewrite this as plus 8x. Okay, so that's how we multiply two rational expressions. Now, what I do want to say is that there's usually an easier way to do this is to actually just factor everything before you even try to multiply. And here's why. Oftentimes, there will be factors in the numerator of one expression that exist also as a factor in the denominator of the other expression. And if that happens, you can do this quote-unquote cross cancellation, right? So let's see how that works. So, probably actually what I would tell you to do is that anytime you want to multiply rational expressions, it's really most often easiest to just deal with the fully factored versions of these polynomials and then just multiply straight across and keep them factored when you do so. So let's see how that works in the following example. So I like to factor everything first and then cross cancel and then multiply. So factor the first one here, we get x squared plus 2x, we get x plus 2 times x plus 1, right? And in the denominator, what do we get? We get x times, what would it be? X squared plus 3, right? Okay, now on the second one, what can I take out? A 2x, right? So we get 2x times x squared plus 3, right? And in the denominator, we would have x plus 2 times x minus 1, I think. Okay, so what you can realize here is that we're going to basically multiply straight across. So since the numerator is going to contain an x squared plus 3 and the denominator is going to contain an x squared plus 3, we can go ahead and cancel those out right away. And also we can cancel x plus 2 with x plus 2. And also we can cancel x with x. And in the end, our final answer is going to be 2 times x plus 1 divided by x minus 1. Okay, so that's, I think, my time for today. Thanks for your attention. If you have any questions, please come to office hours today. And otherwise, I'll see you tomorrow.